Alright, today we're gonna design a super cool humidifier together. Trust me, no guy can resist a mecha sci-fi style. And hey, don't forget to like, comment, and subscribe. So here's the idea. I wanted to DIY a Mars base inspired desktop setup. Since Musk's Mars base is still far, far away, why not just build one right here on my desk? In my head, the humidifier should look like a mini fusion reactor from the future, the energy core of a Mars base. Of course, the most important thing about a humidifier is, humidity. Most humidifiers use ultrasonic atomizers, a little piezoelectric ceramic disc vibrating at high frequency to break water into floating micro droplets. A microcontroller sends a 108 kilohertz signal, and then a 3-wire inductor boosts it to hundreds of volts. Sounds intense, right? But the power is tiny, so no need to worry about getting zapped. Okay, atomizer, check. Now we need a water tank. Add water, drop in a cotton wick. I tried a bunch of bottles, and this frosted one definitely has the best vibe. And if you shine a light under it, yep, that's the look. Now about the motor. Honestly, I wasn't planning to use one at first, but after sketching a few static designs, they felt boring, so I had to add some moving parts. I ended up using an N20 side shaft motor with a 16:1 gear ratio, but that choice made my project timeline totally unpredictable. Still, pushing the limits of 3D printing is half the fun. And then, God said, let there be light. So, RGB LEDs. But I'm not a fan of those rainbow party lights cycling through colors. Instead, I went with a single color breathing effect. Long press to cycle colors, and release when you land on their favorite. And yes, it remembers your choice even after power off. Now for the hardware and software. The easy way would be to buy a cheap and simple pre-made kit, but the lights and motor wouldn't behave the way I wanted them to. Luckily, the control logic is pretty simple. A low-cost STM8 microcontroller is more than enough, powered by USB-C with a power circuit on board. In testing, 5 volts wasn't enough for the motor, so I used a boost converter to bring it up to 10 volts. The motor is rated for 12 volts, so it's totally fine. For the motor driver, I used the DRV8837. The package is tiny, definitely a soldering challenge. The atomizer works as I mentioned. The MCU outputs a 10 kHz PWM, and then the inductor boosts it. I tried building a dry burn protection circuit with ADC, but in practice it didn't detect the condition very well, so I only use it to check if the atomizer was connected. I'm not super familiar with the STM8 environment, but after some tinkering, got it running. The software is pretty simple. I/O functions are set by option bytes, which you can tweak with a debugger or write like normal Flash. Timers, buttons, all that stuff. Come on, you guys learned this in 2nd grade, right? Okay, back to the model. I tested the threads that connect to the bottle. They works fine. But I thought, what else can I add? Then I saw this toy blaster and got inspired. Maybe the Mars energy core needs a cooling system. Something like a container that opens up dramatically. How to make that happen? Well, Lego to the rescue. Big shout out to MOC Masters. I found a design that explains door opening linkages. So yeah, I used a multi-link structure to open the panels. But the question is, how do you set the right arm lengths? Fusion's sketch tool came to mind. You can constrain lines by position. I gave it a try. Yep, that's the feeling. Printed a test part, looks pretty close to what I imagined. Then the next problem, how to push the sliders upward. I remembered assembling a wireless charging kit once that used screw threads to lift the x-axis. So I tried that. It worked in principle, but the 3 sliders sat at different positions. The grooves didn't match, and it needed way too many turns to open fully. Worse, the resistance wasn't consistent, and the motor was struggling. So I had to give up that idea. In the end, I added tracks on a rotating body to guide the multi-link cooling structure. Not gonna lie, I almost gave up on this design too. I tried so many versions. At one point, I even considered adding tiny steel rods to reduce sliding resistance, like in the A1 mini charger. But not elegant and not easy to place. So I optimized the tracks, reduced top and bottom resistance, and printed the track pieces vertically to avoid overhang issues. Then I linked all 3 sliders with a ring to balance the forces. Finally, added some lube, and yes! The motor could smoothly drive the cooling panels open. With the dynamic core done, the rest was just adding polish. I drafted the outer shell design, a matte black base with some color on the panels. Every connection was designed with tolerances, slots, and glue joints, so don't worry, it all fits. The motor even gets its own little building on the base. I did a few detail tests, trying 2 types of buttons, and this one had the best click feel. I cut holes above the nozzle, adjusted the screw slots on the pillars, and added a snap-fit cover plate. I decorated the heatsink panels and added covers to the rotating cylinder. Yeah, maybe it's a little flashy, but hey, go easy on me, guys. After optimizing tight spots, it was time to print. I tested slicing many times. 2 parts needed custom supports. The rest printed fine with default settings. I used 4 filament colors: blue PLA glow in the dark, transparent PETG for some sections, and even printed the bottle in PETG. Pro tip, disable supports for the pillars. I learned that the hard way. After printing, I cleaned the supports with my trusty old tools. Assembly had 2 main steps: glue the covers, then screw everything together. Add some lube, install the cap, drop in the rotating cylinder and bottle, attach the motor and buttons, add the pillars, magnets and atomizer, screw in the top cover, install the PCB, add water, spring, and wick, and done. Smoke test time. Let's see if it actually mists. The logic is simple. Single press to power on off, long press to cycle colors, and release to lock in your favorite. Since the bottle's small, I set the program to auto shut off after 3 hours as a protection measure. If you've watched this far, thank you so much. If you're interested, please be sure to follow along. I'll open source the design files, and I'll post a full assembly guide later. That's all.